Welcome back to our second session of the Masters in Manual Testings from Zero to Hero from the SDT Tech Institutes. If you have wondered how massive the applications like Instagram, Uber, and Amazon is built from the scratch without the whole team collapsing into the chaos, the answer is the SDLC. Think of the SDLC as a professional blueprint. You wouldn't build a house by just buying a bricks and peeling them up, right? You have a plan, a foundations, plumbing, and inspections. In the software world, the SDLC ensures that a product is of the high quality, stays on budget, and most importantly, it is actually what the customer asks for. Today, we are going to deep into the different models and the exactly where we stands and fits into the massive machines. So let's get started. So what is the SDLC? In simple terms, the SDLC stands for the Software Development Lifecycle, which works on the core concept of a structured process used by the IT teams to design and develop the high quality software. It is a step by step procedure used by the software teams to design, develop, and test high quality softwares. Think it as a blueprint of a roadmap that ensures the software is built correctly and on time within the budget. Now let's learn the six main standard phases of the SDLC. First phase is the planning and requirement analysis. This is the where we get what the user wants. We create the SRS documents. If the client wants a food delivery app, we ask what do you want, a search bar? Do you want a GPRS tracking? We write it all down. The second phase is the design phase. Here architecture draws the internal bones of the applications and the designer creates a UI mockups. This is a look and the feel stage. Now third stage is the implementation stage. This is the actual coding stage where the developer takes the designs and turns into the real code. The fourth phase is our testing phase, which is our favorite part. We verify the code against the SRS documents to make sure that it does what it's supposed to do. The fifth phase is the deployment stage. This is when the app goes live on the Play Stores or the web for the publics. And the final is the maintenance stage. Once the application is out, we fix the bugs and updates the application. Now let's move on to the common SDLC models. Not every company follows these models, but there are the different types of the SDLC models like the waterfall models, iterative models, spiral models, V models, and a very popular agile models. Now let's learn at it in the one main ones in advance. Now let's talk about the oldest and the most traditional way to build a software, waterfall model. It is also called as a linear sequential life cycle. This is a fancy way of saying that a project moves in the one direction, straight down, just like a waterfall falling over a cliff. In this model, you cannot just jump around. You must finish the first phase completely before you are allowed to start the second phase. You cannot move the testing until the coding is 100% finished. Think of a waterfall model as building a house. The step one is you decide how many rooms and bathrooms you want. This is the requirement phase. The second one is the design phase, where the architecture draws the blueprints. The third one is the implementation stage, where the worker builds the walls and the roofs of the houses. The fourth stage is the testing phase, where the inspector checks if the wiring is correct or the plumbing is correct and the walls are properly built or not. And the fifth stage is the deployment stage, where you move into the house. The waterfall rule is you cannot start building the roof until the walls are finished. Similarly, you cannot ask to change the kitchen layout after the house is already being built without it being extremely expensive and difficult. Now let's learn the six steps of the waterfall model. The first stage is the requirement analysis, gathering the every single details of what the customer wants. The second is the system design, planning the technical architectures and how the software will look like. The third stage is the coding and implementations, where the developers writes the codes. The fourth stage is the testing phase, where the tester checks the software for the bugs after the coding is finished. The fifth is the deployment stage, where the finished product is delivered to the customer. And sixth is the final stage, which is known as the maintenance. fixing small issues that appear after the launch. Now let's move on to the advantages and the disadvantages of the waterfall model. So advantages of the waterfall model. Because it is rigid and has a specific milestones for the each phases. Disciplined. The phases are completely at one time, ensuring a clear structure. The third is the clear goals. It is the best for the projects where the quality is more important than the speed. Now let's check the disadvantages. High risk. You cannot see the working of the product until the very end of the cycle. The next is it is not for the big projects. It is a poor for the long and ongoing projects where the needs might change. Inflexible. It is a very difficult to go back and change something once the phase is done. Now let's check out the uses of the waterfall model. The project is a short. The requirements are the clear and the fixed. They wouldn't change. The third is the technological, stable and well understood. The project is a low risk and has a strict regulatory requirements like the medicals and the government softwares. Now let's talk about the next model, which is known as the iterative model. Unlike the waterfall model, we try to build everything in the one go. The iterative model takes the different approach. Here the core concept is think of it instead of waiting for the months to see the final product, we build the software in the small pieces. We develop the small parts, test it, and repeat that cycles over and over by adding the new features each time until the whole product is finished. Now look at the diagram. It shows the three iterations. In the iteration 1, we start the core requirements and the analysis. Then we move through the designs, testing and implementations for the just small product. Once the review is done, we review it. Then we move to the second iterations and then third, repeating those same steps by adding the more features each time. Now let's move on to the advantages of the disadvantages of the iterative model. So why would the team choose these models? Let's look at the pros and the consequences. The advantages. The early feedbacks. Because we build a software into the small parts quickly, we can show the working versions of to the clients very early on. The risk management. If there is a risk, high risk features, we can tackle them in the first few cycles and make them sure they work. Flexibility. It is much easier to change the features halfway through the compared to the rigid waterfall model. Now let's look some disadvantages to keep in mind. The resources intensive. These frequent cycles can require the lot of efforts and the times from the whole teams. The design issues. Since we aren't planning everything at the start, we might realize later that the core skeletons or the architectures of the application needs to be changed. Not for the small projects. For a very simple task, the extra works for the managing the multi iterations just isn't worth it. Now let's check out to the uses. In the real world, we use the iterative model in these three scenarios. When we know the main requirements, but some of the finer details might change later. When the company needs to get the working product to the market quickly. This is often called as a MVP or the minimum viable product. And the main when the project is large and complex. Now let's talk about the very powerful approach called as a spiral model. Think of it as a security guard of a software model because its main job is to manage the risk. By the definition, the risk driven SDLC model. It is actually a brilliant combination of waterfall models and iterative model, but with the massive focus on the risk analysis. It is also called as a spiral because the project doesn't move in a straight line. Instead, it passes through the phases in repeated loops or the iterations, which you can see here as a loop of a spiral models. The are the four main quadrants of the phases of the spiral models. Every time when you complete the full loop of spiral models, we go through the four main quadrants. Now let's break them down. The first one is the object determinations. We gather the requirements from the customers, identifies any constraints the project might have. The second is the risk analysis. This is the most important part of the entire model. The team identifies the potential problems like going over budgets or the technical issues, creates the prototypes to their test if the solutions actually works or not. The step third is the engineering phase, where the actual coding and the testing happens. In this first loop, we might build a prototypes, but later loops, it grows into a final products. Now fourth step is the review and planning. Finally, the customer looks at what we built so far. Based on their feedbacks, the team plans for the new next loops of the spirals. Now let's check out the pros and the cons to see if the model is right for your projects. So the advantages. On the plus side, the best models for handling the risk because you find and fix them in the early stages. It is also flexible, allowing you to add the many features even late in the projects. And the customer usually is very happy because you they see the projects in the every loops. Now on the downside, there are also disadvantages. This is a very expensive and takes a lot of the time. It is a complex and requires the highly skilled experts to analyze those risks correctly. Because of this, it is not definitely for the small projects. There is too there is just the too much overhead for a simple applications. So when do you use it? When the chances of the failure is high. It is used in the large projects for the massive systems where the requirement changes over times. And also unclear requirements when the customer isn't 100% sure what the final product just look like. Think of a spoiler model like building a prototype of a new airplanes. We wouldn't just build the whole thing and hope it flies. We build into small models, test the wind risk, build the bigger versions, test the engine risk, and keep spiraling until the final product is safe and final product is out. Now we are moving on to the one of the most critical models for any software testers to masters, the V model. If you are planning a career in testing, listen closely to this one. The V model stands for a verification and the validation model. You think of it as a much stricter and more disciplined versions of waterfall models. In waterfall model, we wait until the very end to start the testings. But the V model changes the game by saying that for every single deployment activity, there must be a matching testing activities. As you can see on the screen, the V model is shaped just like the letter V. The left side represents the verification phase, where we focus on the planning and design. The right side represents the validation phase, which the actual executions of our test starts. And the right at the bottom, that's where the actual coding happens. Like any other model, the V also has its strengths and the weaknesses. Now let's look why the company wouldn't or would choose it to use it. Advantages. The biggest win here is the early testings. Because we start planning and test during the requirement phases. We find the bugs long before the single lines of the code is ever written. This saves the massive amount of the times and money. Second advantage is it is highly disciplined. Every phase has its clear goals and review processes, making it very easy for the project managers to track the progress. The third advantage is finally because the testing happens in the parallel with development. You end up with a very much more stable and reliable final products. Disadvantages. On the downside, we have the late executions. Even though you are planning early, you don't actually get the run the software and see it working until the very end of the cycles. The high risk. This leads to the high risk. If the major design flaw is discovered during the actual testing phase, it is extremely expensive and difficult to go back and fix it. It is also inflexible. It is not good for it for the projects where the customer wants to change their minds and add the new requirements halfway through. So when do you use this model? It is most perfectly used for the small projects. The most importantly, it is used where the requirements are very clear and not going to change. That is why you often see the V models in the medicals and the aviation products, where the safety is the number one priority and the every step must be documented perfectly. In the V model, your job is the tester starts on the day one while the developers are gathering the requirements. You already writing the acceptance testing plan. This parallel way of working is what makes the V model so powerful for the quality control. Now let's move on to the most important models in the software world, Agile model. If you look in the job description for the manual testers, 90% of them ask for the Agile experience. So what is it? In the old days, we built a software like a tall building, one floor at a time. You couldn't change the basement once you reach the roof. Agile is different. It is a flexible. Agile is both incremental and iterative. Instead of building the whole applications in 6 months, we break them into small pieces and deliver in every few weeks. So how does the Agile works? In the Agile, we work in the short cycle called the sprints. Sprints usually last for the 2 to 4 weeks. The Agile process starts with the planning phase. At the start of the sprint, the team decides what three features can we finish in the next 14 days. Then the developers code. This is the important. The testers test them immediately. We don't wait for the testing phase for the next month. We test them today. At the end of the 2 weeks, we show the working piece of the software. We ask the customers, "Do you like it?" If they say no, we change it to the next 2 weeks. This is why the Agile is so successful. So now let's look on to the advantages first. Why Agile is called the king of the modern development. The fastest delivery. Because we work in the short cycles, the customer get to see the and get use of the parts very quickly. This is why it is called as a time to market. Customer satisfaction. The customer is involved in every step. They get to see the progress in every 2 weeks, ensuring the final product is exactly what they wanted. Higher flexibility. This is the agile superpower. If the market changes, our client wants the new features. We can pivot it and add it in the very next cycle. The continuous quality. In the agile, the testing isn't just a phase at the end. We test in every single day, which means the bugs and are caught and fix them immediately. The better transparency. Through the daily meetings, everyone of the team knows what exactly is happening, which leads to the much better communications. But it is not also perfect. Agile has also its disadvantages. Now let's look on to the disadvantages. The scope is creepy because it is easy to add the new features. Sometimes the project just keeps on growing and growing, and it becomes hard and actually hard to finish it. The lack of documentation. Agile focus on the working software rather than the paperwork. This can sometimes makes it very hard for the new team members to understand the history of the code later on. The high commitment. Agile is only works on the if the customer is constantly available to give the feedback. If they are too busy, the whole process slows down. The difficult to resources planning. Since we don't plan every 100% at the start, it is hard to predict exactly how much the final product will cost and when they will last features will be done. The stressful pace. The sprint cycle is so fast, the working is constant in 2 weeks. The deadlines can sometimes be stressful for the development team. So when we use the agile, uh, high risk projects. When the project is complex and the chances of the failure is high, the agile is a small steps that keeps things safe. The massive software application systems that would take a years to build, the waterfall models are much better than handled in the agile models. This is the most common use when the customer isn't 100% sure that what the final product should look like. Yet the agile allows you them to find the right path and there they go. So which one is better? Is agile better or waterfall better? Now let's give you a simple examples which will help you to remember for your interviews. The waterfall model is just like a printed paper map. You plan the whole route before you leave. But if the road is closed or there is the new shortcut, the map can help you. You get stuck. Whereas in the agile model is just like a Google Maps. If you take a wrong turn or the customer changes their destinations, the GPS relocates you and you get a new path instantly. It adapts in the real time changes. Now let's go on to the waterfall and the agile models, the ultimate comparisons. We have looked in the waterfall models and the agile models individually. Now it's time for the ultimate showdown. The most of the students ask which one is the better. The trust is they are just the different tools for the different jobs. Now let's break down to the some important main differences so you can choose the right one for the projects. The structures. The waterfall model is a linear. Think of it as a straight line where you must finish the one phase before the next phase begins. Whereas the agile is a iterative model. It's keep like a continuous loop that repeats in every 2 to 4 weeks. In the requirement phase, in the waterfall model is everything is fixed. You define 100% of a plan and where you start and changes later are very difficult. In the agile, the requirements are flexible. They can change and grow anytime based on the customer needs. Whereas in the testing phase, the waterfall model, the testing is in the last phase. It happens only after the coding has completely finished. Whereas in the agile, the testing is continuous. We test daily alongside the with the developers. Now risk in the waterfall model is highly risky. If there is a mistakes in the original plans, you cannot find out until the end of the projects. Whereas the agile is of the low risk because we review the work in every 2 weeks. The mistakes are caught and almost immediately during the sprints review. In the waterfall model, the customer's involvement is very low. They are at the start and the end. Whereas in the agile project, the customer's involvement is very high. They give the feedbacks in every 2 weeks. The waterfall model gives the one big release. The customer waits for the next month for the final products. Whereas in the agile delivers in the small increments. The customer gets to see the new features and use them in every few weeks. So the waterfall model is basically the linear sequential models, which is the step by step. It is based for the small projects which and gives the fixed requirements. The risk you don't see the final products until the end of the projects. Whereas in the agile models, the it is a highly iterative and incremental, which uses the sprints for the every 2 weeks. It is best for the large and complex projects where the requirement changes in every few weeks or according to the customer needs. The frequent delivery and constant feedbacks. We get the delivery of the software and gets the constant feedbacks from the customer. If they wanted any changes, we can make in the next cycle. Now let's move on to the big shift where the testing fits. As a tester, this is a key insight. In the waterfall models, you are in the single phase at the end, whereas in the agile model, you are a part of a continuous cycle. This has led to the modern concept called the shift left testing. This means we start the testing in the early phase, in the requirement phase, to catch the bugs where they are the cheapest to fix. Remember, testing is just isn't a phase; it is a mindset that should exist in every step of the SDLC. Recap it. We have covered the waterfall model, iterative models, spiral models, P models, agile models. We have also learned the importance of the agile models. As a pro tester tips, to be the great manual testers, you must understand the SDLC and know what exactly, when, and what to test it effectively. Thanks for watching and don't forget to subscribe for the video 3 where we will dive into the SDLC and 7 principles of the software testings. Thank you for watching and goodbye for now.